Question 13. A bag contains some counters. Each counter is numbered 1, 2, 3, or 4. You number each counter from 1 to 4. A counter is taken at random from the bag. The table shows some of the probabilities of taking a counter with each number. So for 1, the probability is 0.1. For 2, the probability is 0.25. For 3, the probability is 0.3. For 4, were not given. Complete the table to show the probability of taking a counter numbered 4. Now in probability, all your possibilities should add up to 1. So all of these would add up to 1. So we have 0.1 plus 0.25 plus 0.3 plus the value of the probability of 4 should all equal to 1. It adds up to 1 in this case. And for you to get the probability of 4, you simply just add 0.1 plus 0.25 plus 0.3. The result you get, you subtract it from 1. The answer you now get will be the probability of picking a 4. When you get your answer, you can test it if it works. You should add all of them together with the new probability you've gotten. They should all sum up to 1. Let's just simply solve this question. Remember, you're not allowed to use a calculator, so you have to add them. You can start with these two, the result, you add to the third one, then you subtract your answer from 1. Let's start. 0.1 plus 0.25. When it's addition or subtraction, the decimals will have to align. So you have over, you can add a 0 here, that's 0 plus 5, that's 5. Then you have 1 plus 2, that's 3. You put your decimal, then 0 plus 0, that's 0. You add the 0.3 to it, 0.3. Note, the decimals will have to align. You add a 0 here at the back to balance it. 5 plus 0, that's 5. 3 plus 3, that's 6.0. We've added the 3 of them, we've gotten 0.65. Then we subtract 0.65 from 1. You have 1, you can make it 1.0 subtracted by 0.65. You can include another 0 here. You start from the back. 0 is less than 5, so you borrow. You can't borrow from 0, you borrow from this 1. If you borrow from 1, you'll be left with 0. This turns to 10. We're trying to work with the 0 minus 5, so you borrow 1 from the 10, you'll be left with 9. And this is now 10. 10 minus 5, that's 5. 9 minus 6, that's 3. 0 minus 0, that's 0. So the probability of picking a 4 is 0.35. Question 13b says Mike takes a counter at random from the bag. He records the number on the counter and replaces the counter. Let's say he gets a 1, he takes it, records it, and puts it back in the bag that replaces it. What this is saying is that in probability, when you have replacement, that means the total doesn't drop. The total still remains. For example, if it's 20, it's still 20. If it were to be without replacement, if there were 20 counters and you take 1, your new total will be 19. But here you have a total as still the total, it doesn't change. He repeats this process until he has recorded 40 numbers. 40 numbers, you can have like 10 ones, 20 twos, 8 threes, and the rest will be counter 4. But we're not certain. But he did for 40. Work out how many times you should expect to record the number 3. To record the number 3, we have to use this probability factor of 3, that's 0.3, and multiply it by the total number of times you took out the balls. So you have your answer as 0.3 times 40. If it were to be 100, you multiply 0.3 times 100. Whatever this value is, this probability represents its share of the total. So 0.3 times 40. If you're very good with this, you know, to take this decimal out or behind the 3, which ends up out, you take this 0 from this 40. So you have 3 times 4, that's 12. But if you're not very good with that style, you can have your 0.3, then 40 multiply. Note the 40 doesn't have a decimal, and you don't need to align them like you do with addition or subtraction. You have 0 times 3, that's 0. 0 times 0, that's 0. Then you have 4 times 3, that's 12. You can't write the whole 12, you write 2 and you carry 1. Then you have 4 times 0, that's 0. The result, which is 0 plus 1, that's 1. You add them together, you have 0, 2, 1. That's 120. Note that there's a decimal here, that's 0.3, and there's only one digit, which is 3, behind the decimal. So in our answer from our right, you take one digit and add a decimal in front of it. The digit here is 0, so you put the decimal in front of 0. That you have 12.0. 12.0 is still the same thing as 12. So the answer to question B is 12. Another way of doing it is equivalent method. When you add all this together, it gives you 1. So for counter 3, out of 1, the probability is equivalent to 0.3. Then out of 40, the probability is equivalent to x. Then you cross and multiply. That's x times 1 and 40 times 0.3. So you have x equals 0.3 times 40. 0.3 times 40, you have your answer as 12. And you can also solve this by converting first to a fraction, then you multiply. 0.3 as a fraction, you move the decimal behind the 3. That's same thing as 3 over 10 times 40. You can make it 40 over 1. 0 cancels 0. You have 3 times 4, that's 12. Question 13C says, find the smallest possible number of counters in the bag. That's the least number of total counters that can be in the bag. For solving this question to be easy, we convert all these decimals to whole numbers. And the best way to convert it is by multiplying by 100. So you multiply all of them by 100 first. Then see if we can break it down to the lowest term by dividing through. If there's any number that can divide them all through, we'll see that as we go on. Let's just start. We start with 0.1. If you had multiplied 0.1 times 10, you get 1. If you had multiplied 0.25 by 10, you get 2.5. That means 10 moves the decimal from in front of 2 to behind 2. And that doesn't work. We need whole numbers. And we'll have to multiply all of them by the same number. So we go with 0.1 and multiply it by 100. That gives us 10. We have 0.25 times 100. That gives us 25. We have 0.3 times 100 is 30. 0.3 times 100 makes the decimal move twice. 1 and 2. In between the movement, you put a 0 inside. That's how you get your 30. And the last one is 0.35 times 100. That gives you 35. From counter 1 to counter 4, you can have them like this. Counter 1 is 10, counter 2 is 25, counter 3 is 30, and counter 4 is 35. They all have 5 inside them, so we can divide all through by 5 to get them to their lowest term, since we're looking for the smallest possible number of counters that can be in the bag. We have 10, we have 25, we have 30, and we have 35. 5 can go in all of them. 10 divided by 5, that's 2. 25 divided by 5, that's 5. 30 divided by 5, that's 6. And 35 divided by 5, that's 7. The least number of counter 1 we can have is 2. The least number of counter 2 we can have is 5. The least number of counter 3 is 6. And the least number of counter 4 is 7. We add them together. That's 2 plus 5 plus 6 plus 7. 2 plus 5 is 7. 7 plus 6 is 13. 13 plus 7 is 20. So the least or the smallest possible number of counters we can have in the bag is 20. There might be an easier method of solving this, but this is what this page has at this time. The concept behind is converting it from decimal to whole numbers, then see if you can bring it down to the lowest term, then add them together.